So when it comes to concept of graph, we had learned concept of in degree and out degree. If it's a directed graph, then the number of vertices, edges which are originating from that particular vertex is the out degree, and number of edges which are incident on that particular vertex is the in degree. But it's an undirected graph. Number of vertices on which it lies. So I welcome you all once again for another session on graph. Yesterday we had seen implementation of graph, representation of graph using concept of adjacency table, and today we'll take this discussion further. Now we'll try and apply various algorithms. The first one we'll try and apply is how to find in degree and how to find out degree. So when we go on to represent a graph, we'll have a look at this particular diagram of the graph. So yesterday we represented a particular graph. So this was the graph that we had represented. This was the graph that we had represented. Number of vertices are 4, and we represented this graph. Now, if you watch this particular graph, since it's a directed graph, from vertex number 0, there are 2 edges which are originating. So out degree of 0 is 2. So how to find out degree? If I take sum of all the elements on that particular row, because over here, what we have, let me highlight it for you. Here, what we have are nothing but adjacent vertices. Where it is F means false, here 0, that means there is no adjacent vertex. Whereas these are 2 adjacent vertices. So out degree is like how many edges are originating from 0 and incident on some other vertices. So if I take sum of all these elements, I'll get out degree of 0. And that was 2. If I take sum of all these elements, I'll get out degree of 1. So 1 ka bhi out degree is 2. Let's check. This is the 1 and this is another one, 2. If you look at out degree of 2, that's 0 because there is no edge which is originating from vertex number 0. Okay? And vertex number 3, there are 3 edges which are originating. One goes to A, 0, other goes to 1, other goes to 2. So out degree is so and so. But if you are asked to find in degree, that's equally simple. If I take sum of all the elements on this particular column, I'll get the in degree. That means 0 ka in degree is 1. So let's see. There is only this particular vertex which is incident on 0. Okay. 1 ke liye, it is 2. That is 0 and 3. Let's see. 1 is coming from 0. Other is coming from 3. Then for 2, it is like 3. 1, 2, and 3. Look at this. From 0, from 1, and from 3. And for third, it is only 1. And that is coming from 1. Let's see. This is the only one which is incident on 3. So it is very simple. Once you have created a table, you just have to take sum of all the elements on that row or the column. And you will correctly get in degree or out degree. Now in our code, we actually have written 2 different functions. One function that we have written is to find, one function that we had written yesterday in our code was to find the in degree of all the vertices and out degree of all the vertices. Another code that we had done was to find in degree or out degree of any particular vertex. So let's have a look at the interface that we had created, the header file that we had. So sometimes user is interested in knowing, let me know the out degree of. Sometimes user is interested in knowing, let me know the out degree of a particular vertex. So 2 different versions of that same thing. So let's have a look at the other version which is there. Android Studio शिकायचंच नसतं. Android Studio IDE ठीक आहे. Android language, Android as a coding शिका. Android Studio शी काय मतलब नाही. Android Studio वापरायचं कसं शिकायचं असेल तर प्रश्न वेगळा आहे. But Android, here we go. Java यायला पाहिजे थोडं. You can very well do it Android. Here we go. Now, if you look at this particular code, now that we discussed what is in degree and what is out degree, we have one function in degree, we have another function out degree. These two functions are not taking any parameter. That means they are meant to find in degree and out degree of all the vertices. Whereas this function in degree int and in degree int, this is to find in degree and out degree of a particular vertex. So let's jump onto that particular code. Yesterday, we had represented a graph, we also displayed the graph. Now we'll focus on finding in degree and finding out degree. Assume the graph is already created, it has been represented in this fashion. Assume. We will manually trace the code. Okay. We directly give a call to function in degree. So you are adjustable.degree. So we come to this function in degree, and what are we doing? We are saying in degree of all the vertices in the graph. Okay. So I could just take it on the same line. Why take it on another line? So I just say in the graph. And then I have put /n. And then I say int I equal to 0, I less than number of vertices. So currently our graph has only 4 vertices. So this for loop will cycle through all the vertices. Correct? We are interested in finding in degree. Or let's find, okay, let's find in degree. So in this example, if you look at in degree, was sum of all the elements on a row or the column. Which one was the in degree? Sum of all the ones, row or column? No, row was always out degree, column is always in degree. Here, look at vertex number 0. In degree is only 1. Vertex number 0, in degree is only 1. Out degree is 2. If I take sum of all the elements on the row, I'll get out degree. If I want, if I take sum of elements on this column, I'll get in degree. So instead of taking true and false, we have taken it as 0 than 1. This 0 and 1 will make our job very easy. Okay. So let's jump onto the code. Here I say I equal to 0, I less than number of vertices, and I plus plus. And I say in degree is 0. That means for every vertex, I'll reset the value of in degree to value as 0. Reset करायची गरज आहे. Otherwise, what will happen is the first vertex in addition will get added to the next vertex and so on. So I'll write over here. So we reset the in degree for each vertex. So in will be representing our in degree actually. I say j equal to 0, j less than number of vertices, j plus plus. So it's just a nested loop. Right? I and j. Both will vary 4 times. In our case, number of vertices are 4. What am I doing? In degree is equal to in degree plus in degree ka value for the first time is 0. Table of j comma I. Now for the first time j ka value 0, I ka value 0. So it's going to take a total addition of these two elements, 0, 0. That is this false. For us, false is 0. So this has been added. Huh? And then it goes up and say j plus plus. Now j will become 1. So it'll say in degree that is 0 plus table of 1, 0. I is still 0. So 1, 0 is this row, whenever we access a table, it's always row, column. So if I say 1, 0, that means 1 number ka row and 0th number ka column. So that is false again. Okay. So 0 is added again. So in degree ka value abhi bhi 0 hai. And then j increments. J now becomes 2. Okay. So 2, 0. That's also false. That is also 0. Then j becomes 3. Is 3 less than 4? Yes. In degree la column, out degree la row. So what we are doing is right now we are keeping I constant, column number constant, and what we are varying is only row number. Okay. Now if you find this thing confusing, what I could do over here is I could just quickly change this. Could call this I ki jagah, because I for us is the column and j for us is the row. Pardon? होगा ना, मैंने गलत जगह पे रिप्लेस किया. यहाँ नीचे करने की जगह मुझे यहाँ करना चाहिए था. हो जाता जहाँ डिक्लेयर करो वहां करोगे तो इट विल इमीडिएटली गेट चेंज. तो ये आपका कॉलम और रो नंबर. The column is still 0. Row number increments. Row now becomes 3. Is 3 less than 4? Yes. Table of row comma column. Actually, we would like to have row is in inner loop we have taken. So row comma column. So row ka value currently is 3 and column is filal 0. So 3 comma 0. 3 comma 0 is 1. So in degree ka value now becomes 1. And we come over here for vertex number column. Column ka value for the first time is 0. So we are saying for vertex number 0, in degree is 1 and HD and L. So we have printed in degree for vertex number 0. Is that right? And then after we have done this, the outer for loop has not, this is end of the call for loop, correct? And this is end of for loop. End of row for loop. Now here, we have come out of this particular loop, but we'll go here and increment the column. So our column value will be 1. Is 1 less than 3? 4? Yes. So again, in degree set to value as 0. So previously in the in degree had become 1 zala, the current reset to 0. Now we are saying row equal to 0, row is the number of vertices, row plus plus. Now every time over here we are changing the row, but we are keeping the column fixed. Correct? So now row ka value will be 0, 1. So 0, 1 will be this t now. So that will be added. So in becomes 1, row plus plus, row becomes 2. 2, 1. 1, row ka value becomes 1. 1, 1. 1, 1 is this? False. Okay, and then again row increments, row becomes 2. So 2, 1. False. Then row increments becomes 3. Is 3 less than 4? Yes. So that is also added. 3, 1. That is true. That means 2 and 2. 1 and 1 becomes 2. So, and then row becomes 4. Is 4 less than 4? False. We come out vertex number 1 ka in degree is 2. Likewise, we'll do for vertex number 3 and vertex number 4. Now, this time we have come out of this for loop. Okay, now it will go and column increments. Column now becomes is 2 less than 4? Yes. So we go inside in degrees again, reset to value as 0. Again, we start row equal to 0, row is the number of vertices, row plus plus, table of row comma column. It is 0, 2. Column value 2 है. So ये 0, 2 मतलब ये t 1 that is added. So it becomes 1. So row increments. Row now becomes 1. So 1, 2. This is added. True. 2 हो गया in degree, yeah? And row plus plus. Row now becomes 2. Okay, 2, 1. False है. And then 3, 1. ये true है. So in degree of 2 is 3. इन तीनों का total ले लिया हमने. Yes or no? So we have taken the total and row plus plus. Row का value will now become 4. Is 4 less than 4? 4 less than 4? False. बाहर आएंगे ये output print करेंगे. In degree is 3 and column plus plus. Column का value now be 3 है. Is 3 less than 4? Yes. So we'll do the same operation for row number 3. That means first time it will be 0, 3, then 1, 3, then 2, 3, and then 4, 3. 3, 3. Okay, the result will now be 1. Okay. And so on, the degree will be printed. And then we say column plus plus, column becomes 4. Is 4 less than 4? False. We come out of it. So that's how we have found in degree of all the vertices. Suppose you are asked to find the degree of any particular vertex. So you pass the vertex number. Suppose here you are passing the vertex number. Can you see this? Okay, in degree of vertex number 3. Now what's the degree of vertex number 3 right now here? Ekach se? 1, na? Yes or no? Yes. So if you are passing 3, so we come to this particular function this time around. Here function lalo. So we say I equal to 0. I equal to in degree is equal to 0. I equal to 0. I less than number of vertices. I plus plus. So actually this I is nothing but your row column. Row A. हा रो चेंज करणार आहे दरवेळी. कॉलम आपला फिक्स्ड आहे. कॉलम कुठला 3. वी हॅड पास 3 ना. So row equal to 0, row is the number of vertices, row plus plus row row and vertex. Vertex is 3, huh? So value of row will vary from 0 to 3. Moment it becomes 4, it will come out. मग काय होईल 0, 3, 1, 3, 2, 3, 3, 3. Moment it becomes 4, it will come out. म्हणजे सगळे ऍड झाले का? This is 0, 3. This is 1, 3. This is 2, 3. And this is 3, 3. So we have kept the column constant, whatever vertex is for past, and what we are changing is only the number. Well, row number 0 third element, row number 1 third element, row number 2 third element, row number 3 third element, and so on. So that's how we can find in degree of a particular vertex. Now that so keep in mind, if you are finding in degree of all the vertices, we'll have to take nested loop. This is to find in degree of a particular vertex, and this is to supply all the vertices. Now that we have found in degree, it's time for us to find out degree. Now, exactly opposite. Correct. So we give a call to this out degree function. Now here, again we say out is a variable that we have created that has been initialized over here to value as 0. We say out out degree. नहीं आउट डिग्री फिलहाल कुछ और कुछ नहीं. आउट डिग्री कैलकुलेट करके हम उसमें स्टोर करने वाले. That will change. So we are saying for I equal to 0, I less than number of vertices I plus plus, out degree is reset to value as 0. Okay. Out degree is reset to value 0 for each vertex. Then we go here and J. So what is varying over the J? That is a column is varying. So what we are going to do now, we are going to keep the row number fixed. And for every row number, we are going to change the column. Okay, let's see. I'll show you the logic. We have discussed the logic first. Row equal to 0, row less than number of vertices, row plus plus, out degree is set to 0, column is equal, so that means this nested loop is n square. Row 2, 0 to number of vertices, and this also 0 to number of vertices. A nested loop is simple. So we come here, table is equal to out is equal to out plus. This is combination operator. It's as good as saying out is equal to out plus table of row comma column. So table of row comma column, row for the first time is 0, column for the first time is 0. So this will add 0, 0. If you look at this particular chart, 0, 0 is false. So out degree is still 0. Then we are still inside this for loop. So column increments. Column becomes 1. Huh? Row is still 0. So 0, 1. So 0, 1 is true. 1 has been added. Then row column again becomes 2. Is 2 less than 4? Yes. So 0, 2. So 0, 2 is again true. So that's also added. Column becomes 3. 3 less than 4 hai kya? Yes. So 0, 3. 0, 3 is false. So this 2 have got added. So out degree for vertex number 2, row number 0, that is vertex number 0 is 2 is what has been printed. What we have found is right now out degree, correct? But that was out degree for vertex number 0. But after they have come out of this particular loop, row increments becomes 9. हा इनर फॉर लूप मधून बाहेर आलो आपण पहिल्यांदा बाहेर आलो ना ह्या इनर फॉर लूप मधून आपण पहिल्यांदा बाहेर आलो तो रो नंबर विल नाउ बिकम 1. Initially it was 0, correct? Row plus plus will make it 1. Is 1 less than 4? So our degree is again set to 0. So for row number 1, that is vertex number 1, we'll again do the same thing and calculate. But this time it will be 1, 0, 1, 1, 1, 2, and 1, 3. 1, 0, 1, 1, 1, 2, and 1, 3. So likewise, we'll do it for all the vertices. And so we'll get in degree of all the vertices in this particular graph. Is that okay? Then suppose we are asked to find out degree of a particular vertex. At vertex number 0 ची आपल्याला out degree find करायची. So we pass vertex number 0. When you come over here, we're saying out is equal to 0. This I could immediately change it to as row equal to 0, row less than number of vertices, row plus plus, table is equal to table plus var comma row. So var ka value for the first time is 0. So this is not row, this is actually column. Let's say column equal to 0, column number of vertices, column plus plus, table of var comma column, var ka value is 0. So it will be 0, 0, then 0, 1, 0, 2, 0, 3. Moment column becomes 4. This condition is false. And we come out. And so while coming out, what we are doing is we are returning the out degree. So whatever we have returned, that will get printed over here. So this is what we have not yet discussed. So I'll mark it as comment. And what we have completed, we'll again run through and check whether our idea is correct or not. So we have represented a graph. We have found in degree. We have found out degree. We have found in degree of all the vertices and in degree or out degree of a particular vertex. आता इथं तुम्ही युजर कडून मागूनचा पाठवला असा which vertex out degree would like to find. Last question. Pass that value. जी काय pass करते. इथं I have taken a sample value as if it's vertex number 3. But you could always ask the user, please enter the vertex number with the in degrees to be found. Pass that in degree, vertex number. You'll find. Okay, so let's run the code once again to see whether in degree and out degree are correctly calculated. We'll take the same diagram, and we'll check whether in degree and out degree are correctly calculated. Let's run the code. I'm terminating it since I did not save. We made some changes to this particular code. Correct. So it's better that we save and then compile, so that we compile and then run, so that we are sure that there are no compile time mistakes. Enter the total number of vertices. We had 4. What we'll do is, just for sake of understanding, have the graph also in the background. Have a look at that graph and we can enter the values. we should actually see the actual graph rather than seeing the table. Let's have it. Okay, so there is the graph. So please enter number of adjacent vertex number 0. Please enter number of adjacent vertices. How many adjacent to vertex number 0? टेबल हमें जनरेट करना है. हाँ, तो वो टेबल क्यों देखे हम लोग? हमारे पास तो जिंदगी में ग्राफ रहेगा ना. So we would like to have the graph table representation. Output नंतर बघायचं आपल्याला. Enter the number of adjacent vertices for vertex number 0. How many are there? 2. Enter the adjacent vertex number 1. 1. Second. 2 है क्या पक्का? 2. Vertex number 1. Vertex number 1 के लिए how many adjacent vertices? 2 है. Which are those? 2 and 3. Vertex number 2 के लिए कितने adjacent vertices? 0. Vertex number 3 के लिए कितने adjacent vertices? Which are those? 0, 1 and 2. So when we have done that, it has correctly represented the graph. Let's check out the representation. 0, 1, 1, 0. 0, 1, 1, 0. 0, 0, 1, 1. 0, 0, 1, 1. All zeros. All zeros. And yes, 1, 1 and 0. It's correctly being represented. Now let's find the in degree. So it says vertex number 0 का in degree is 1. Have a look at this graph and tell me vertex number 0 का in degree 1 ही है क्या? Yes. Vertex number 1 का in degree. Vertex number 1 का in degree 2 है. Vertex number 2 का in degree 3 है. Vertex number 3 is in degree is 1. Then out degree for all vertices. Vertex number 0 out degree is 2. Vertex number 1 out degree is 2. Right? Vertex number 2 out degree is 0. It is originating from that particular vertex. Vertex number. You all cannot see my mouse pointer. Vertex number 3 जो है, vertex number 3 का out degree check करते हैं 1, 2 and 3. Okay. Now vertex number 3 का in degree कितना है? 1. Yes or no? Vertex number 1. Yes or no? Yes. Vertex number 0 का out degree 2. नहीं. This functions were written. This was a function and this was a function which is printing in degree and out degree for all vertices. And sometimes you're interested in knowing in degree and out degree of only particular vertex. Hi, नहीं बोलता. You could ask, what difference will it make? You could always ask, you could pass any vertex. Here I have directly passed 3. So you could ask, please enter the vertex number whose in degree is to be found. The word and the word value will pass over here. What difference will it make? Is that okay? Now let's go ahead with some very interesting concept called as DFS and BFS. Now that we have represented the graph correctly, let's go ahead with the next topic now. Now suppose you have this particular graph and you have to traverse this graph for whatever reason. There are multiple ways in which you can traverse this graph. Traverse means visit every vertex inside that particular graph. So it is a connected graph. Disconnected graph means आपण सगळ्या vertex जाऊ शकणार नाही. Path will not be there. Okay, so if it's a connected graph and you have to visit all the vertices inside that particular graph, so there are two ways to do that. One is BFS, another is BFS. BFS stands for breadth first search and BFS stands for depth first search. It's an algorithm which is BFS. Let's look at the first one, that is DFS. Okay, depth first search, DFS. It's a traversal for graph is roughly analogous to pre-ordered traversal of an ordered tree. So if you have done concept of trees, the implementation of concept of pre-order traversal is the same thing over here. So pre-order traversal of tree and graph is one and the same. It says, suppose that the traversal has just visited vertex number V or V, any particular vertex, and let W1, W2, Wk be the vertices adjacent to V. I'll show with the help of an example that will help you understand this concept better. But valid definition mode. It says, suppose you have just visited vertex V. Suppose there is V1, V2, V3 as a vertex. So V1 la visit kiya suppose. And suppose W1, W2, Wk are the vertices adjacent to V. So suppose there are 2 or 3 adjacent vertices to V. Then we shall visit W1 and keep W2 and Wk waiting. W bakiche will keep it waiting. Now when I say waiting, what are we going to do? The W2 चे adjacent असतील त्यात जे vertex मिळतील त्यांना visit करणार त्याचे बाकीचे waiting. After visiting W1, we traverse all the vertices which are adjacent before returning to traverse W2 to Wk. हे W2 बाकीचे राहिलेले नंतर traverse करणार. Depth first means एक आपला level wise tree मध्ये आपण level wise print करतो that's breadth first. Depth first means we'll go to the depth of that tree. एका sequence मध्ये आपण जाणार आहे. I'll take an example to help you understand this. Suppose this is a vertex that we have, a graph that we have. And suppose you said, sir, start with vertex number 0. There are more than one output that we can get for DFS. There is not necessary that we'll get only one output. And you can get multiple output and all of them may be correct. The diagram comes from 10 and 12. Suppose we start from vertex number 0. Now tell me which are this is undirected graph. So all the edges on which it lies are its adjacent vertex. All the it's like lying on all the edges, correct? So all the vertices which are lying on the same edges are adjacent to it. So tell me what is the degree of, there is no in degree out degree over. So what's the degree of vertex number 0? कौन से? No. 1, 4, 8. 2 is not adjacent. Only 1, 4, and 8 are adjacent. Correct? Now, so after 0, you could go to 1. Okay. Kunal may go to 4. And he may go to 8. The order doesn't matter. So you have 3 choices. Either after vertex number after vertex number 0, I can go here. I have that choice. Watch me very carefully what I'm doing. I go here, correct? So for vertex number 0, I have traversed this vertex now. But these are also adjacent which are still waiting. Correct? But I'll keep them aside. Now, of vertex number 1, which are the adjacent vertices for vertex number 1? 2 and 4. Correct? Say probably I visit this, 2 I visit. So for vertex number 2, which are adjacent vertices? 3. So I visit that. Now for 3, which are the adjacent vertices? कुठलाच नाहीये. त्याच्या आधीचा वर्टेक्स कोणता 2? 2 तो विजिट झाला आहे ना, परत काय विजिट करणार? त्याच्या आधीचा वर्टेक्स कुठला होता? 1 चा कुठला adjacent vertex राहिला का अजून? So I'll visit 4. Correct? And which, so output काय आला आपलं पहिल्यांदा? 0, then 1, and then 2, and then 3, and then आता 4 झालं आपण. बरोबर? 4 झालं. Which are adjacent vertex to vertex number 4? 5. नाही, 0 आहे, 1 आहे, and 5 आहे. Out of this, 0 and 1 are already visited. So only option left is to go to 5. 5 is also visited now. आता 5 चे adjacent कोण आहेत? 6 and 8 आहे. You could go to any one of them. समजा आपण 6 ला गेलो. इथं 4 नंतर आपण 5 ला आलो आणि 5 नंतर आपण गेलो 6 ला गेलो. 6 चे कोण adjacent आहेत? 5 and 7. 5 is already visited. So I'll only visit 7. Correct? 7 ला visit केलं. आता 7 ला adjacent कोण आहे? 6 already visited. 6 ला adjacent कोण आहे? 5 already visited. Correct? बस 5 चा 8 राहिलाय. So 8 will now be visited. Correct? 8 चा adjacent कोण होता आधी? 5 आणि हा 0. 0 पण सगळे visit झाले. So we started depth first. But this was the output that we got. 0, 1, 2, 3, 4, 5, 6, 7, 8. Order मध्ये आला line मध्ये. But it could so happen. Never. That's what I want to show. It could also so happen 0 nantar you go to 8. So first is visited as 0, but these are also adjacent to 0, correct? Okay. You go to 8. Now 8 ala. 8 चा adjacent कोण आहे? Only 5. So only 5 will be visited. 5 चा adjacent कोण आहे? 4 and 6. You may visit any one of them. समजा तुम्ही 6 visit केला. 6 चा adjacent कोण आहे? 7 visit केला. आता there are no more adjacent vertices. मग आधीच्या vertex ला गेलो 6 ला गेलो. 6 चा कोणी आहे का? नाही. मागे आलो 5. 5 चे कोण राहिले का visit करायचे? 4. So I have to visit 4. Right? If I go to 4, 4 चे adjacent vertex कोण आहेत? 0 and 1 and 5. But this is visited. This is also visited. Only thing that is we will go to 1. इथं आलो आपण. Then we go to 1. 1 चे adjacent vertex 0 and 2 आहे. We will go to 2. And 2 च्या नंतर only option left is 3. So look at 0, 8, 5, 6, 7, 4, 1, 2, 3. That's also DFS. Is that okay? Now, how is it to be implemented? The concept is implemented. कसं जायचं मागच्या vertex ला? Whether this is an area where we see a very good application of concept of stack. Stack शिकलेला तरी stack which works on the principle of first in last out. Okay.
First in, first out. QA.
First in, last out. Okay. Last in, first out. First in, last out. Yeah, last in, first out. Both are same. So now this is a good example for us to use concept of stack. So let's see how to use stack to solve this particular problem. आता आपण logic बघितलं, but how to implement this? Okay, so let me show you implementation. पहिले एक diagram मध्ये बघू आपण implementation, and then we'll go ahead with the actual code. Okay, so concept पहिली कळायला पाहिजे, मग code करतो. So now that we have seen the concept, now we'll see the implementation of the concept discussion wise, and then we'll go to the code. 3 stages. So I'll keep this graph aside. आपण हा ग्राफ ठेवू आपला. Open up Excel. What I'm going to do here is I'm going to create a stack. I'll create a stack of few elements. Assume this is your stack. आपला स्टॅक आहे. त्याला स्टॅक ऑफ व्हर्टायसेस. नाव लेट्स सी द लॉजिक. काय लॉजिक मध्ये तुम्ही सांगा तुम्हाला कुठल्या व्हर्टेक्स पासून सुरू करायचंय? 0 पासून. युअर चॉईस. ओके, वी स्टार्ट विथ 0. So what we'll do is we'll push 0 into the stack. या स्टॅक मध्ये आपण 0 पुश करणार. So I push 0 into the stack. I push 0 into the stack. Is the stack empty? No, 0 आहे. So till the stack does not become empty, we'll keep on repeating some operations. काय करायचं? स्टॅक मधला एलिमेंट पॉप आउट करायचा. So I pop out the element from the stack and that is 0. मी पॉप आउट करायचा स्टॅक मधला एलिमेंट. ठीक आहे? ऑपरेशन लक्षात घ्या काय काय करायचंय. Pop out that element from the stack. Okay. And print that element. स्टॅक मध्ये 0 पॉप आउट केला आणि तो प्रिंट केला. आता 0 पॉप आउट केलाय आणि 0 मी प्रिंट करणार आहे. मग हा मी इथं पॉप आउट केला आणि तोच मी व्हॅल्यू प्रिंट केली. तर इथून स्टॅक 0 मधला हा व्हॅल्यू गायब झाला. स्टॅक मध्ये पुश केला आणि तोच एलिमेंट पॉप केला आणि तो प्रिंट केला. तो अज्युम करो की the 0 has now been printed, has been popped out. ब्ल्यू रेड कलर म्हणजे तो गेलाय सपोज, असं अज्युम करू आपण. हा हा बाहेर आल्याने प्रिंट केला. मग तो पॉप केला की तो प्रिंट केला. आता कुठला एलिमेंट प्रिंट केला आपण? 0 केला. जो प्रिंट केला ना एलिमेंट आपण, whichever element we have printed, what we'll do now is we'll check what are the adjacent vertex for vertex number 0. सांगा मला vertex number 0 चे adjacent कोण आहेत? We'll push them into the stack. मग स्टॅक मध्ये गेला पहिला 1, then आला 4 आणि तिसरा कुठला आहे? 8. मला एक सांगा आता, why did I print 1 on the first line आणि बाकीचे खालच्या लाईनला असं का केलं असेल मी? 1 इथे लिहिला आणि बाकीचे खाली लिहिले असं का केलं? 1 त्याच रोज 0 ला लिहिला आणि वर 0 नाही लिहिले. 0 has been popped out. बाहेर काढून टाकला तो, डिलीट झाला. पुश्ड इन 0 पॉप चेक स्टॅक इज एम्प्टी नाहीये. मग तो पॉप केला आणि तो प्रिंट केला आणि त्याचे ऑल ऍडजस्टमेंट व्हर्टेक्स वे पुश इनटू द स्टॅक. इज द स्टॅक एम्प्टी? No. Now tell me which is the element if I pop out, which is the element that will get popped out? 8 and because stack works on the principle of last in first out, correct? आता डिलीट काय होणार? 8 डिलीट होणार, 8 प्रिंट होणार. जो डिलीट होईल तो प्रिंट करायचा. जो प्रिंट केलाय त्याचे सगळे ऍडजस्टमेंट व्हर्टेक्स पुश करायचे. सो टेल मी which are the adjacent vertex for vertex number 8? It has now been deleted. कलर का चेंज होत नाहीये. काय म्हणणार? काय गमत काय? आवाज आपला काहीतरी गंमत असेल. But we know for sure 8 has been deleted. आपण कॉमा टाकू, जो ज्या कॉमा टाकला तो डिलीट. 8 has been deleted. Which are adjacent vertex for vertex number 8? So 5 is added first and then 0 is added. Okay? अरे पण 0 is already visited. आपल्याला ते कळणार कसं whether is already visited or not. काय करणार आपण? Let's change the order. We'll do something more. What is more that we'll be doing? Let me just show you. काहीच नाही. So before we start with this operation, assume that no vertex has been visited. What will assume? No vertex has been. एक पण vertex visit नाही केला असं assume करणार. But then what's an indicator to specify की अरे एक पण vertex visit झालेलं नाहीये हे सांगण्याचं काय concept आहे? So what we do is we create one array called as visited. एक array आपण घेतला. या array ला नाव दिलं आपण visited. काय नाव दिलं?
Visited.
It will keep a track of all the vertices which has been visited. Array ला नाव दिलं आपण visited. Okay. हा index येतो त्या arrayचा 0, 1, 5 तर नाही आपल्याकडे 4 पण नाहीये 4 आहेत. So 0, 1, 2, 3 असणार आहे. Yes or no? इंडेक्स आहे त्यांचे. अरे विल इनिशियली सेट अरे नाही इथं नाही 4 नाही जास्त येते किती टोटल येते 8 आहेत. हा एक्झाम्पल घेतो आपण या एक्झाम्पल मध्ये 8 आहेत आपल्याकडे. येस और नो? Correct? 0 to 7. Correct? I initially set all the vertex over here to value as 0. That's clear, na? All the elements I'll set to value as 0 initially. Value as 0. This 0 will be indicating not visited. Zero will indicate it has not yet been visited. ज्यावेळी कुठला आपण vertex visit करू, we'll just change this particular flag from 0 to 1. Correct? Now user starts with vertex number 0 for the first time, correct? So we're going to push 0 into the stack. Yes? 0 आपण stack मध्ये push केला. And then we're going to pop out 0 from the stack. We pop out 0. After popping out 0, 0 was pushed in, correct? The moment you push in, you change this flag from 0 to 1. Visit zala. That means before you push in, you're going to check whether this element has been already visited or not. The 0 select kila, that time this visited array may 0 position was 0. That means it's not visited. So for any vertex, the corresponding value flag, these are flags, huh? These are all flags. If there is 0, that means that vertex has not yet been visited. So 0 upon print kila, 0 adjacent vertex kon hai? 1 goes here, 4 and 8. Correct? One for it. Which is array. Now, after this, we'll pop out the topmost element. Kya topmost element? 8 pop out karo. 8 has been popped out. 8 has. एक मिनट. No. उससे कोई मतलब नहीं. हम ग्राफ को ट्रैवर्स कर रहे हैं. And for traversal of graph, we are using stack. Stacks and queue on their own have no application. त्याचा उपयोगच काही नसतो. काय केलं? फर्स्ट टाइम टाकलं बाहेर काढले. काय केलं त्याचं? There is no purpose of it. They come into action while we are using with some other data structure. So stacks and queues are used in various algorithms to fulfill your requirements. On their own, they are of no use. मी फक्त आपण जे अकॅडमिक्स मध्ये फक्त स्टॅक क्रिएट केला आणि तो वर्क करून दाखवला. पुश पॉप. That has no meaning. It has to be put to use. आता आपण त्याला स्टॅकला वापरतोय कुठल्या कामासाठी. फर्स्ट सेमिस्टर मध्ये स्टॅक मध्ये तुम्ही जे केलं तर काय फक्त जे अॅडमिट एक्सप्रेशन इव्हॅल्युएशन केलं तिथे ऍप्लिकेशन होते. करेक्ट. सो 8 has been pushed in. Sorry. Before we push in, sorry, हे चुकलं आपलं. Which are the adjacent vertex for vertex number 0? 1, 4 and 8. तर पहिले चेक करायचं is 1 visited? तर त्याला मार्क करा 1 and then 1 is moved in. तर ओके? काय म्हटलं? Then 1 is visited. Okay. Which is the next adjacent vertex to vertex number 0? Is 4 already visited? If it is not visited, I'll mark it as 1 and I'll visit 4. Then which is adjacent vertex of vertex number 0? 8. Is 8 already visited? Okay. Here's 7, 8, 8 अच्छा 9 है म्हणजे total. Is 8 already visited? So I'll first mark it as 1 and then I'll push it 8 over. Okay. Next. Which will be the one to be popped out? 8 will be popped out. 8 is the one that will be popped out. The 8 print zala. Now tell me which are the adjacent vertex to vertex number 8? 1 minute. 5 है पहला. Is 5 already visited? No. So I'll mark this as 1 and I'll push 5. अभी क्या मैंने?
0 already visited.
Not visited.
The 8 for 0 is not visited and 5 also not visited.
8 देखो क्या वैल्यू?
0 ने visit किया ना
8 का वैल्यू क्या है यहाँ?
8 का वैल्यू 1
यानी विजिट हो चुका है. ठीक है. अब 5 की बात कर रहे थे हम लोग. 5 का वैल्यू 0 था तो आई मेड इट 1 एंड आई पुश इनटू स्टैक. 8 का कौन है और एडिशन वर्टिसेस 0 है. But 0 is already visited, so we'll not push it. So we will visit only those vertices which have not yet been visited. Okay. Now which is the next one to be popped out?
5.
5 is the next one to be popped out. Very correct. 5 is the next one to be popped out. So 5 is printed. After printing 5, we check which are the adjacent vertices for vertex number 5. 6, 4 and 8. Correct? So first suppose you take it as 6. Is 6 already visited? No. So we can visit. I add 6 over here. Correct? Then which is the next one? 4. 4 is already visited. 8. 8 is already visited. So they are not pushed in. Okay. Kutla pop out will next. 6 is the next one to be popped out. 6 is the next one to be popped out. The 6 has been popped out. It has been deleted. Okay, it has been deleted. That's the next one to be popped out. And now tell me which are the adjacent vertices for vertex number 6?
7.
7 and 5. So 7 is not visited. I mark it as 1 and visit 7. Next one is 5. But 5 is already visited. Yes or no? So that's not pushed into stack. Okay, now which one will be deleted? Tell me. 7 is the one to be deleted next. The 7 is the vertex that has been deleted next. Other 7? Now which are the adjacent vertex for vertex number 7?
6 and 5.
6 already visited. Next one to be deleted will be 4 now. Next one to visit is 4. Is 4 already visited? 4 pop out करतो आपण आता. 4 print केला. Which are the adjacent vertex for vertex number 4?
1 0
1 at a 1. पहिल्यांदा 1. 1 is already visited. Next. 0 is also already visited. Next. 5 is also already visited. काहीच नाही राहिलं. The next one to be popped out will be 1. Correct? Next one to be popped out is 1. So 1 is printed. After printing 1, okay, we'll check what are these adjacent vertices. क्या है adjacent vertex of 1? 1 at a time. 0 is already visited. Then 4. Acha, 2. 2 is not visited. So we'll mark 2 as 1 and we'll visit 2 push into stack. Yes? Okay. Next, which one more? 0. But 0 is already visited. Now, which one will be the next one to be deleted? Two is now popped out. Two is popped out. 2 is printed. Okay. Now, which are the adjacent vertices for vertex number 2? 1 is already visited. 3 is not visited. So we push 3 into the stack. Okay. Now, which is the next one to be popped out? 3 is the next one to be popped out. 3 is popped out. 3 is printed. Correct? 3 is printed. Now tell me which are adjacent vertex to vertex number 3? 2. One, 2. 2 is already visited. Is the stack empty now? Moment the stack becomes empty, we can say we have visited all the vertices. Apply output ala. Let's see how our output has gone now. In this case, our output has been from 0, we went to 8, correct? From 8, we went to 5. From 5, we went to 6. 6 to 7. 7 to 4, 9. Then the 6 la 5 la, and then 5 to 4. 5 to 4, then 1. And then 2. That was DFS. Depth first search. ठीक आहे. आता आपण ज्या पद्धतीने कोड लिहितोय त्या वेळेमुळे ते असं आउटपुट आलंय. तर मी थोडंसं चेंज केलं असतं. पुश करताना एलिमेंटची ऑर्डर चेंज केली असती. वेगळं असं. पण नोट करा, आता हा फक्त ब्ल्यू लाईन्स चेक करा तुम्ही. इट इज कनेक्टेड ग्राफ विदाउट सायकल्स. म्हणजे हा कनेक्टेड ट्री आहे. डेफिनेशन घेतो कुठं सायकल नाहीये. कुठं सर्किट नाहीये. इट्स लाईक अ ट्री. याला जर मी वेगळ्या प्रकारे रिप्रेझेंट केलं असतं तर ते ट्री कसं दिसतं असं तुम्हाला दाखवतो मी. इट कुड हॅव सपोज मी 0 पासून चालू केलंय. 0 ने गेलो आपण 8 ला. 8 ने आलो आपण 8 ने आलो आपण 5 ला. ओके. 8 ने आलो आपण 5 ला. फ्रॉम 5 देर आर 2 ब्रांचेस. एक आला 6 आणि एक आला 7. एक आला 4 and then 1 and then 2 and then 3 असा ग्राफ येतो. Actually it's a free tree. Okay. Should we go to the code now? And remember, code should not be any different than the logic that we have discussed. आपण जे डिस्कस केलं तसंच कोड पाहिजे. मला तो चाहिए. एवढा मोठा कोड विचारच नाही. दे विल ओनली आस्क यू डीएफएस, ओनली बीएफएस, सगळं नाही सांगणार. तेवढंच विचारतात. फक्त प्रॅक्टिकल
स्टेप लिहायला मोठे स्टेप असतात. 8-9 स्टेप. एक 5 मार्क्ससाठी
नाही कोड म्हणजे आयडिया अल्गोरिथम किंवा कोडच्या
5 मार्क के लिए एक पेज लिखो.
चालेल सगळ्यांना. हा फोटो घेऊन ठेवा तुमच्याकडे. नाही एक मिनिट, आय शेअर विथ यू. आय शेअर. मला फक्त आठवण करून द्या तुम्हाला शेअर करायची.
उघड आहे नित्यावर.
हे
हा.
माझ्या रिक्रुटमेंटचा व्हॉट्सअप आहे प्लेसमेंट. आपल्याकडे रोज इंटरव्ह्यू चालू असतात ना, त्या इंटरव्ह्यूला कोण काय कोणती प्रोसेस आहे. आपली बॅच let's go ahead with the code now. Now we would like to traverse the graph in DFS way, correct? So here we give a call to DFS, adjtable.dfs. So moment I give a call to DFS, we are passing the vertex to begin with. Suppose we said vertex number 0 or 1, where you would like to start on it. Then I check first, is the vertex number correct or not? If vertex number is less than 0 or if vertex number greater than equal to number of vertices, I say enter the starting vertex for DFS traversal. Agar galat hai to. Here we'll also print one more message saying पहिला मेसेज आला आपला वर्टेक्स नंबर सो अँड सो इट डज नॉट एक्झिस्ट. चुकीचं दिलं तर आपल्याकडे 8 वर्टेक्स आहे, तुम्ही म्हणलं वर्टेक्स नंबर 12 वरून स्टार्ट कर, नाहीच आहे तर कोण स्टार्ट कर, -5 वरून स्टार्ट कर, देयर इज नो 5. So we are writing this loop only for the purpose of validation. So if the vertex number supplied is invalid, so in that case I'll ask the user to enter the vertex number once again. This will keep on working as long as you do not supply the right vertex number. Another choice that you have is if the user supplies the wrong vertex, you will print an error message and go back saying this vertex number is invalid. Return. असंही करू शकलो असतात ना. So instead of forcing the user to enter, so other way could have been, मी ह्याला comment out करतो. Other way could have been, I could have written something like this: if right? खतम. So either you give the right vertex, if you give the wrong vertex, I'll just return. प्रोग्राम नाही, त्या फंक्शन आहे, फंक्शन पुढे जे असेल ते जाऊया. वर्टेक्स नंबर डज नॉट एक्झिस्ट. काय म्हणलं काय आलं कुठला और output नसतं. It's only meant for joining two conditions. Now truth table for or काय असतो, false or false is false, true or anything is true. Okay, we'll print this message and we'll immediately return. But then it should not be C out, it should have been error, है ना? And error stream, when you send something, make sure that you also flush it. Return back. High choice. स्ट्रीम फुल नाही झाला तर डेटा त्यात राहील, पुढचे आउटपुट प्रिंट होतील, नंतर कधीतरी तो डेटा तिथे येईल. तर डू वॉन्ट टू आउटपुट टू प्रिंटेड आउट ऑफ ऑर्डर और इन करेक्ट ऑर्डर?
करेक्ट ऑर्डर.
तर सांगा मला. म्हणजे दर्शनासाठी एक लाईन आहे, ज्या लाईन मध्ये लागले त्याच लाईन मध्ये बाहेर पडतील. दर्शनासाठी 2 लाईन आहे. ठीक आहे. आता मला सांगा कोण कुठल्या लाईन माणूस पहिल्यांदा पोहोचेल? 2 लाईन आहेत. कंडिशन काही इश्यू ते कुठली लाईन, एका लाईन नंबर 1 मध्ये जास्त लोक आहेत आणि लाईन नंबर 2 मध्ये कमी लोक आहेत. कुठली लाईन पहिले पोहोचेल? आणि तुम्ही त्या दोन्ही, एक मित्र एका लाईनच्या मागे थांबला, एक तुम्ही थांबला मागे.
कमी लाईन
का ते स्लो चालणारे असतात, हळूहळू पुढे सरकत असतील तर?
जास्त लाईन मध्ये पहिले डिपेंड करतो कोण किती पूजा करते.
Correct. मग तुम्ही मला गॅरंटी देऊ शकता का? नाही ना. सो वेन द आउटपुट इज गोइंग टू द मॉनिटर, दीज आर 2 डिफरंट चॅनल्स. एक सी आउट आहे, एक CRR आहे. तो कुठल्या आउटपुट पहिल्यांदा जाईल माहित नाही आपल्याला. So if I send some message to CRR, I'll first make sure it immediately goes to the monitor.
कोणी नाही, फक्त एरर आहे.
हा?
त्याची एरर म्हणजे फक्त एरर आहे.
हा. तो मग नॉर्मली काय होतं, टिल द टाइम द स्ट्रीम डझंट बिकम फुल, इट डज नॉट गो टू द डेस्टिनेशन. आपल्या तो एकच मेसेज आहे, आपली स्ट्रीम फुल होणार. फॉर लॉंग टाइम इट विल रिमेन देअर अँड यू मे से सी आउट, सगळं सी आउट चालू आहे आणि नंतर काहीतरी इथून यायला मेसेज येईल की error, and message. So if you send something to error stream, since these are 2 different channel of communication, just make sure it is clear. आणि झंझटीत पडायचं नसेल तर सगळं सी आउट. जे नॉर्मल कॉलेज सगळंच काय असेल ते सी आउट. ठीक आहे. आणि ask you to find the difference between CRR and C log. तुम्ही फाइंड करा, सांगा.
CRR अनबफर्ड असतं, म्हणून त्याच्यात जरा एरर असलं तर ते इमिजिएट
लवकर
शो
जातं.
करतं. आणि C log मध्ये ते बफर्ड असतं, त्याच्यामुळे ते स्टोअर करून ठेवतं आणि त्यानंतर
Correct.
मॉनिटरला.
मग आता मी CRR वापरलाय तरी फ्लश म्हणतोय. अनबफर्ड म्हणजे त्याची कॅपॅसिटी 0 आहे. सो व्हॉट यू विल सेंड गोज टू दॅट स्ट्रीम डायरेक्टली. लॉग मध्ये फ्लश करणं कंपल्सरी आहे, ERR मध्ये कंपल्सरी नाहीये. बट देन स्टील वी सॉ आउटपुट गॉट प्रिंटेड आउट ऑफ ऑर्डर. काय हे 2 वेगळ्या स्ट्रीम्स आहेत. तर दोघे स्ट्रीम चालू असताना कुठल्या स्ट्रीमवर प्रोसेसर काम करतोय ते माहित नाही आपल्याला. ज्याच्यावर काम करत ती पुढे जाईल. फ्लश हे पहिले तुम्हाला क्लिअर करा बिफोर यू डू एनी अदर वर्क. हे झालं. So let's go. So I take one array called as visited, and that array has been created dynamically depending on how many vertices you have. All the elements inside the array have been initialized to 0. Correct? Okay. 0 indicating element has not yet been visited. Vertex has not yet been visited. Okay. आपल्याला आमचं purpose आहे. Can I initialize all elements to value as 0? Okay. Then we take a stack. Now you wondering how stack ala kudun? Actually, we have created. Correct. Yes. So we have created another class called as stack. एक अजून एक called as stack. And I had template आहे. That means it can be stack of anything. तुमच्यासाठी तुम्ही इथं t च्या ऐवजी int म्हणा. That's good enough. तुम्हाला stack of integers पाहिजे. So I say int stack of max size. Max size value is 100. तर त्या stack मध्ये 100 elements असतील. And this is implement stack. Initially stack का top का value is -1. Okay. And destruct होताना पण -1. Stack empty आहे का? Top ची value -1 असेल तर stack is empty. Means array चा index is -1. That means the stack is empty. If the stack is not full, then I'll add element to the stack. But before I add the element to the stack, I'll increment the value of top. आणि जर स्टॅक फुल असेल आणि त्यात तुम्ही व्हॅल्यू ऍड करत असाल तर आय प्रिंट एरर मेसेज saying stack overflow. Likewise, pop करत असताना, if the stack is empty, if the stack is not empty, then I'll get the element from the topmost position and then decrement the value of top. मैं पहिले top ची value घेईन आणि नंतर top ला decrement करेन. And that is the value, and that value will be returned. And if the stack is empty, I'll print an error message saying the stack is empty. Stack झालेला आहे तुमचा, so I'll not be discussing. झालं ना first section stack. So that's a simple stack that we have created here. So here I create an object of type stack. S capital class name है, S small object name है. And we say stack dot push var. तुमचा जो पहिला vertex आपण push केला, in case it was 0 for the first time for us. बरोबर ना, 0 तो आपला पहिल्यांदा. So that has been pushed in. And then I check while stack not empty. एक element empty ची condition काय होती? While top is equal to -1. So when I push the first element, top ची value काय बनेल? 0 stack मध्ये. So while stack not empty, the stack is not empty. If the stack is not empty, I pop the element from the stack. जर आप लॉजिक नुसार करा म्हणजे आपण जे डिस्कस पॉप द टॉप एलिमेंट ऑफ द स्टॅक अँड वी से वर म्हणजे तो कुठला आहे तर तो वर्टेक्स नंबर जो आपण पॉप केला 0 प्रिंट केला आणि तो म्हटलं आय इक्वल टू 0, आय लेस दॅन नंबर ऑफ वर्टेक्स आय प्लस प्लस टेबल ऑफ वर कॉमा आय इज इक्वल टू 1 म्हणजे काय चेक करतो वर इज द वर्टेक्स नंबर ओके अँड आय इज द ऍडजस्टंट वर्टेक्स. मग आपण तो विचारतो टेबल ऑफ वर कॉमा आता आपला हा जो टेबल होता लास्ट एक्झाम्पल मध्ये आता 0 आहे सपोज तो 0,0 इक्वल टू 1 आहे का? नाही आहे. 0,1 इक्वल टू 1 आहे का? आहे. जर असेल तर मी चेक करतो व्हिजिटेड मध्ये 1 इक्वल टू 0 आहे का? नाही. व्हिजिटेड मधला फर्स्ट पोझिशनचा एलिमेंट 0 आहे का? म्हणजे तो व्हिजिट झालेला नाहीये. मग तो व्हिजिट झाला नसेल तर मी तो स्टॅक मध्ये पुश केला आणि व्हिजिट मध्ये मार्क केला 1. Correct? Check if the vertex has not been visited. Either correct? And then I plus plus I now becomes 2. So table of 0,2 equal to 1 है का? Yes. तो adjacent आहे. तो visited of 2 equal to 0 है का? आहे. विजिट नाही आला. विजिट नसेल झाला तर तो स्टॅक मध्ये पुश केला आणि मार्क केला 1. सुरुवातीला देखील आपला जो वर्टेक्स नंबर 0 आहे तो आपण आधीच मार्क केलाय 1 स्टार्टिंग वर्टेक्स. करेक्ट? याला आय प्लस प्लस आय नाव बिकम्स 3. 0,3 इक्वल टू 1 आहे का? नाही. ओके दिस कंडिशन इज फॉल्स. आय प्लस प्लस आय बिकम्स 4. इज 4 लेस देन 4? फॉल्स. लूप मधून बाहेर आलो. लूप मधून बाहेर आला. So your for loop ends over here. For loop ends over here. And high end of while loop. While's end. आता आपण for loop मधून बाहेर आलो. So after we come out of for loop, we check is stack empty? Not empty? Empty नाही. दोन एलिमेंट्स आहेत. कुठले कुठले आहेत? 1 and 2. मग आता पहिल्यांदा पॉप केल्यानंतर कोण पॉप होईल? 2 होईल. 2 पॉप केला, 2 प्रिंट केला. आणि त्याचे ऍडजस्टंट वर्टेक्स असतील तर पुश केले त्याचे लॉजिक नाही आपण डिस्कस केलं. दॅट्स हाऊ इट शुड बी. म्हणजे आपला कोड जो आहे इट शुड नॉट बी इवन दिस स्लाइटली डिफरंट देन व्हॉट वी हॅव डिस्कस. आपण जे डिस्कस करतो तोच कोड लिहिला पाहिजे. काय वेगळं काय केलं? कॉन्सेप्ट जे आपण डिस्कस केले आधी एक्झाम्पल तेच कोड लिहायचं. म्हणजे कोड पार्ट नाही करायचा. लॉजिक समजून घ्यायचा आणि ज्यावेळी पाहिजे त्यावेळी तो कोड लिहिता आला पाहिजे. त्यामुळे कॉन्सेप्ट इज क्लिअर. त्याला हेच DFS traverse is done. हा सब एक प्रश्न येतो DFS traverse. We are done within no time DFS traverse. आता एकच राहतो आपला तो DFS traverse सोल्युशन टेकअप तुम्हाला कळलं आहे? डाऊट नाही कोणाला? सोपे की नाही? किती आपल्याची काय करायचं काय करायचं. आपला हा डायनॅमिक आहे किती पण मोठा ठेवायचा. सो आज मी काही चेंजेस केले आपण ह्या कोड मध्ये. सो आय अगेन शेअर दिस पर्टिक्युलर कोड विथ यू ऑल. डेटा उतना ज्यादा है तो क्या करेगा?
ऑलरेडी ओपन
ऑलरेडी ओपन ही है क्या? वह चेक करा फाइल आली का? ओके, एवरीवन अंडरस्टूड. ते अनझिप करून घ्या फाईल आणि नंतर कोड चेक करा. उद्या येताना जस्ट हॅव अ लुक ॲट DFS, नजर फिरून या. आय क्विकली कम एक्सप्लेन द बेसिक वर्क इज डन. So tomorrow after we finish DFS, we start with the next part in graph.